For section, or rather topic 6, we're going to look at solving linear equations containing decimals, okay? So in the previous, let me situate here. In the previous video, we looked at solving linear equations that contain fractions, and we learned how to just get rid of the fractions right off the bat. Just get rid of them, clear the fractions, and then you have a nice, pretty, much easier to work with equation to solve. The reason for that is you could solve the equation by keeping the fractions in there. It would just be really complicated. It would have a lot of extra steps, a lot more chances to make mistakes. So we just clear the fractions, okay? Now, you can do the same thing if you have an equation that contains a series of decimals, okay? You don't have to here, okay? With fractions, I insist that you clear the fractions. With decimals, I kind of leave it up to the student. There is a trick that makes this kind of a little bit easier to work with, not so cumbersome, okay? But it's not nearly as powerful as clearing those fractions, okay? So steps for clearing decimals from an equation. Multiply all terms by the power of 10 that will clear the largest number of decimal places. I'll explain that a bit more in just a second. And then solve the resulting equation using the steps from topic. I think that should actually say topic 4. I think that's a typo on my part, okay? So when you're dealing with multiplying powers of 10 by decimals, there's this cool thing that happens. So let's say we have some decimal. We're going to make it really generic. So just 0.15. Okay, if I were to take 0.15 and multiply it by 10, I get 1.5. If I were to take 0.15 and multiply it by 100, I get 15. If I were to take 0.15 and multiply it by 1,000, I would get 150. Okay, so what is the pattern? What is happening here? Well, what is happening here is for each zero in the power of 10, we're moving the decimal to the right one time, okay? And that's just, I mean, you can multiply these out by hand if you want to. This is just the shortcut, okay? So for each zero in the power of 10, we can move our decimal to the right once, okay? 1, 2, we move it 1, 2, 1, 2, 3, we move it 1, 2, and then 3, add in a 0, okay? So when we say that we're going to multiply all terms by the power of 10 that will clear the largest number of decimal places, go through your problem and see which number has the most decimal places. Decimal places being the number of digits after the decimal point, okay? If the largest number of decimal places is 2, you would multiply everything by 100, all terms by 100. If the largest number of decimal places is 3, you would multiply all of your terms by 1,000, okay? Now, I do want you to remember a couple of things. So powers of 10 would be like, let me go back to black. Powers of 10, in case you are forgetting, powers of 10 would be like 10, 100, 1,000, 10,000, and so on. So basically 1 followed by zeros, those are your powers of 10. The second thing I want you to remember is terms are separated by addition and subtraction. Okay, so when I say multiply all of your terms, ignoring parentheses, look to see which chunks are separated by addition and subtraction or also an equal sign. Okay, so let's go ahead and just practice this. I think it'll make a bit more sense when you see it in practice. Again, I am not going to require that you clear decimals. I will require that you clear fractions. Okay, so solve each equation. We have for part A, 0.48x plus 3 equals 0.2 times x minus 2. So if we look at this term right here, we have 2 decimal places. If we look at this term right here, we have 1 decimal place. Always go with the larger number of decimal places, okay? So if you have 2 decimal places, so I'm just using DP as decimal places, you want to multiply by the power of 10 that has 2 zeros. So we want to multiply everything by 100, okay? So let's show this. Again, I'm going to show the work for multiplying all of your terms by this power of 10. This is equivalent to multiplying all of your terms by the LCD, okay? So we want to take 100 times 0.48x. We want to take 100 times 3. And then here's the tricky part. On the right-hand side of the equation, even though you see this minus sign right here, this is one term, okay? Terms are created with multiplication. They are separated by addition and subtraction. So until you distribute, this is one single term. So I'm going to get 100 times 0.2 times x minus 6. Okay, and that can be a little tricky for some students. Okay, now let's clear those decimals. Remember, for each 0 in your power of 10, you move the decimal to the right that many times. Okay, so if I have 100 times 0.48, I can move my decimal in 0.48 two times, which makes it 48x. 100 times 3 is just 300. And then this is where you have to be careful. You're just multiplying these two pieces. And then when we later distribute, that power of 10 kind of distributes with the 0.2, okay? So 100 times 0.2, well, I can move my decimal to the right twice, which would make 0.2, 20. And then I just leave the stuff in parentheses alone. When I distribute the 20, that power of 10 kind of gets pulled along with it, okay? So now we have just a regular old equation that we can solve. And this is, I mean, it is easier to solve than the one with decimals. You won't really have to use your calculator as much, okay? So let's see. The left-hand side is fine. We get 48x plus 300 equals, well, now I need to distribute 20. So 20 times x, and then 20 times negative 6 is negative 120, okay? And now I've got the left-hand side is as simple as it's going to get. Ditto for the right. We have a single variable term on both sides, a single constant term on both sides. We want to apply the addition property of equality. So I want to move my 20x's from the right to the left. Since it's positive, we think of this as plus 20x, and we undo addition with subtraction. All right, we simplify on the left. 48x minus 20x is 28x. We leave the plus 300 and the equals. And then on the right-hand side, 20x minus 20x is 0. So we would say the 20x is canceled, but really they just become 0. So 0 minus 120, negative 120. Okay, now we've got the x's in a single term. We want to isolate that x term, the variable term. So my issue now is the plus 300. I need to undo addition, so I'm going to subtract. So 300 minus 300 is 0. So we'd say the 300s cancel. 48 or 28x plus 0 is just 28x. And then negative 120 minus 320 is negative 420, okay? And at this point, we've got a single variable term equaling a constant. We can go ahead and apply the multiplication property of equality. We undo this multiplication of 28 and x with division. So we divide both sides by 28. 28 divided by itself is just 1. 1 times x is x. And let's see, I've got my calculator here. I don't happen to know off the top of my head what 420 divided by 8 is. Oops. So 420, not 8, divided by 28. Ooh, I just about made a big mistake. So we've got negative 420 divided by 28. We get negative 15. All right, so I only had to use my calculator once, whereas if I kept those decimals, there was a higher chance that I was going to have to use the calculator more times. Just kind of depends on the person. Again, I don't totally care if you clear your decimals, but I absolutely insist that you clear your fractions, okay? Now, if we were to write this kind of fancy in that formal set notation, we would do squiggly brackets, 15, squiggly brackets. This translates to the reader that the solution set contains the value negative 15, okay? One more example just to make sure we're good. We have 0.04x plus 0.06 times, in parentheses, 10,000 minus x equals 480. Well, I have two decimal places here. I have two decimal places here. And we kind of already know from part A that if you're trying to clear two decimal places, you want to multiply by the power of 10 that has two zeros. So we want to multiply everything by 100. Okay, so I'm going to go ahead and do the multiplication of each term by 100. So I get 100 times 0.04x plus 100 times 0.06, and then in parentheses 10,000 minus x. Now remember, we don't multiply all three pieces here by 100. We just multiply these two pieces together, and then when we distribute, that 100 kind of gets pulled into that set of parentheses. And then that's going to equal, let's see, where are we at? 100 times 480. Okay, so now we can clean things up. 100 times 0.04 allows me to move my decimal to the right twice, which would make that just 4x. You can hear my dog in the background. I'm so sorry. 100 times 0.06. Well, the 100 allows me to move my decimal 2 times to the right, which makes that plus 6. And then in parentheses, 10,000 minus x. We'll distribute the 6 in just a bit. And then 100 times 48. Here's a trick. You take the 1 and you multiply it by the 48. That's just 48. And then you add the zeros. How many zeros do we have? We have 1, 2, 3. So we add 3 zeros here. Okay? So now we have an equation that's just kind of easier to look at. It's easier to work with. Okay? So let's see. We need to distribute first. So I'm going to drop down my 4x. So 4x is just 4x. And then I'm going to distribute 6. So 6 times 10,000. Well, 6 times 10 is 60. So that would make this 60,000. 6 times negative x is minus 6x. And that all equals 48,000. Okay? So on the left, we have two terms that contain x's, and we want at most one term that contains an x. So 4x minus 6x is negative 2x. And then drop down your 60,000, and that still equals 48,000. These little kids, they make me so mad. They don't play with Winnie anymore. When she was a puppy, they would play with her. And now that she's a big dog, they're like, meh, whatever. And I just want to go away, you little brats. Anyway, I didn't say that. We're talking about math right now. Okay, so I need to isolate my negative 2x. My issue now is this plus 60. I need to move the plus 60, or the plus 60,000. So I would subtract 60,000. And don't let all of these zeros get you bent out of shape. Sometimes when we see all these zeros, we're like, meh, we can't do the math. We can still do the math. There's some tricks. So 60,000 minus itself is just 0. Okay, so we get 2x, well, negative 2x on the left. But then on the right, don't let all the zeros flip you out. Just think, what is 48 minus 60? Well, 48 minus 60 is just negative 12, and then tack on all those zeros. It's that simple, okay? You could certainly use your calculator if that kind of stresses you out a little bit. Use the calculator if you need to, okay? Now we're finally at a point where we have a single variable term equaling a single constant term. We need to apply the multiplication property of equality. We want to undo the multiplication of negative 2 and x, so we divide. Negative 2 divided by itself is just 1. 1 times x is x. So again, we'll get lazy and we'll say the negative 2's cancel. Just know why. They cancel because it's like getting really dark. They cancel, there we go. Because when we divide negative 2 by itself, we get 1. Okay? And then, again, don't let all the zeros flip you out. What is negative 12 divided by negative 2? That would just be 6. And then keep all those zeros. So there we have it. Our final answer would be 6,000. Okay, now we can write this kind of fancy. I'll do it down this way. And we could say the solution contains the value 6,000. Okay, so that is clearing decimals. I've said it a few times. I want to say it again. I'm not too concerned about you all clearing the decimals. I'm very concerned about you clearing the fractions. I am checking to make sure you know how to clear the fractions and that you can do it successfully. When it comes to decimals, I leave it up to the student. You can clear them if you like it. You don't have to if you don't want to. Okay, now in the next video, I think, don't quote me on this, but I think the next video we talk about proportions. Yeah, so the next video we'll talk about proportions, and then we'll wrap up this very long worksheet by classifying equations. So 2 more videos to go and then we're done.